Good morning friends. Today we are going to discuss about magnetic field due to currents. As we all know, and it was proved by Hans Christian Ørsted, the scientist who has bridged a link between the electric current and magnetism. He has proved that every current carrying conductor would act as a magnet. This was proved by his activity. He has placed a compass nearby a current carrying conductor which has caused deflection in it. The current carrying conductor has caused deflection in a magnetic compass. This magnetic compass changes its direction when it is kept nearby a current carrying conductor. Only a magnetic field can influence the direction shown by the magnetic compass. As there is no magnet would be present around this magnetic compass, only the current carrying conductor is present around this magnetic compass. He has inferred that this current carrying conductor would have influenced the change in the direction of the magnetic compass. So from there, he has concluded that this current carrying conductor has a magnetic field around it. So, what about the direction of this magnetic field? We won't be able to see any lines of force, the magnetic field lines around this current carrying conductor. So, we are unable to decipher the direction of these magnetic field lines around this current carrying conductor. For that, we are going to understand some activities which in turn makes us to understand the directions which are around this current carrying conductor. So we shall see how the magnetic field lines will be present around a straight current carrying conductor now. So by performing this activity which we are going to discuss in a while, will let us know how the magnetic field lines will be present around different shapes of different conductors, different current carrying conductors. So right now we are going to discuss the magnetic field direction around magnetic field. This in turn is indicated by B. Do remember that the magnetic field is in turn indicated by B. So right now, here onwards we are going to state B as magnetic field such that our time will be reduced. Generally the symbols will be used to reduce our time in writing and reading it out. So the B, the magnetic field direction around, the magnetic field direction when a straight current carrying conductor is considered. So now we shall see how this straight current carrying conductor will have the magnetic field around it. What is the direction of the magnetic field around it? So we shall perform this activity. Try to remember whatever I am saying. Try to remember that you are going to perform a thought experiment whenever I am going to discuss any activity with you guys. So here, as I am going to say you about an activity, you just try to imagine whatever I am saying right in front of you. This is called a thought experiment which was performed by a great scientist called named Einstein. You might know about Einstein, who has enormous enthusiasm towards our science. If you want to increase interest towards the science, just try to know about the great heroes. So this is the general principle I would teach my students to increase interest towards science. In whichever the field you wanted to increase the interest, you just try to know about the heroes of that field. If you want to increase the interest towards science, you have to learn about, or else you have to know about the great heroes of science. One of such great heroes is Sir Einstein. So know about Einstein, sir. He used to make his students perform this thought experiment. I suggested. He used to teach astrology to the astrophysics, I can say. So he used to teach astrophysics to his students, and he won't be able to bring sun to the earth, right? So he used to make his students to move towards sun, to reach sun in their thoughts. So this kind of experiments was conducted by Einstein the Great. So even I request you people to imagine whatever the science activities you are going to listen from your teachers as similar to his students. So try to understand the activity, any activity in the science in an imaginative way, such that you can understand it in a clear way. So we shall see the activity. What is the activity actually? So we should try to consider a table. So just imagine a table is in front of you. Okay, just a table is in front of you, and what you do is you are going to place a retort stand upon this table. A retort stand will be placed upon this table such that a straight wire can be considered. A hole would be placed in this table. A hole is made in this table such that a wire can be passed right away from this retort stand. There will be a knob in this retort stand. From this retort stand, a straight wire would be passed through this hole which was made in the table to the bottom of this table. You have to keep a weight over here such that you will ensure a stiff wire which would be passed from retort stand to the bottom of the table. I hope everybody is able to imagine. ఓ మంచి టేబుల్ తీసుకోవాలి. ఒక టేబుల్ తీసుకొని ఆ టేబుల్ లోపల ఒక హోల్ చేయాలి. హోల్ చేసేసి ఏం చేయాలా, పైన రిటార్ట్ స్టాండ్ దగ్గర వైర్ టై చేసేసి, ఐ మీన్ టు ద నాబ్, యాక్చువల్లీ యూ హ్యావ్ టు పాస్ ఇట్ త్రూ ఎ నాబ్, and you just tie it here such that it remains straight, and you place a weight over here such that the entire setup, the entire wire would be stretched tight and make it in a condition of straight wire. So here the other end of the wire is taken, and this end of the wire is also taken, and it is connected to a 9-volt battery. The battery is of 9 volts. You ensure that there is a key between the circuit. The key is present in the circuit. And there is one interesting question. So what kind of wire can we consider a wire which we use to tie to the poles? No, such kind of thickness is not considered. So we have to specify the thickness of the wire. The thickness of the wire generally measured in gauges. So here the thickness of the wire or sheet, whatever it is, the thickness would be measured in gauges. The thickness would be measured in the units called gauges. Here we are going to use a thickness of 24 gauge. 24 gauge, you are new to this term called gauge. So what is this 24 gauge? 24 gauge is nothing but 0.607 mm thickness. The wire is of thickness 0.607. So generally, is this the thickness which we use in our household? No. In households, the thickness of the wire changes, and here in this activity, the wire which we have considered for this activity is quite different from the wire which we use in our household, circuits. So what is the thickness of the wires which we use in our household circuits? That is of 12 to 14 gauge, 12 to 14 gauges. Try to remember, as the gauge value decreases, the thickness increases. Thickness increases. That means our household wire thickness is much more greater than the wire thickness which we are using in this activity. So what is the general thickness? 12 to 14 gauge means that is nothing but 12 gauges is 2.06 mm. And this is 1.63 mm. Means generally it would be from 1.63 mm to 2.06 mm. See, 14 mm to 12 mm. Sorry, 14 gauge to 12 gauge. As the number decreases, the thickness would increase. You can see here it would be 1.63. It is 2.06 mm thickness of wire. So the wire which we are considering in this activity is quite different from the wire which we use in our household circuits. So we may fail if we are going to take the thickness, because it requires much more voltage to conduct the experiment. If we use the wire which we use in our household circuits, the battery would demand, it would demand much more stronger battery which has more potential difference. So we are decreasing the thickness such that the experiment can be conducted with a small battery. So the thickness which we are going to use is 24 gauge, that is of 0.607 mm. So what ultimately we are going to do, the final aim of this activity, you have to remember the final aim of this activity is to know the direction of the magnetic field around a straight current carrying conductor. So let us suppose here there is a key, right? So yeah, we have to suppose one more event. So first we have taken a table and we have made a hole in that plane surface of the table, and we have placed a retard stand. We have tied a wire which would pass through that hole which we made in the plane and beneath the table even, and we have to ensure that the wire stays straight during this activity. And try to remember this hole as the center. This hole as the center, you make a circle. This hole as the center, you ensure that there is a circle, and upon this circle you try to place magnetic compasses. Upon this circle which you have made a hole as the center, you try to place some compasses. Some compasses in the sense the number would go from 6 to 10 magnetic compasses. So these are the magnetic compasses which would be placed around the hole as the center. So we shall see what exactly is the use of these magnets. Let me educate you upon this. So whenever you switch on, and you imagine that there are some compasses around this hole upon the table. Now you try to switch on the circuit. The circuit is switched on. Now the circuit is switched on. So suppose that this circuit is switched on and the current starts flowing from positive terminal of the battery to the negative terminal of the battery. That means the current starts flowing in this way, and from top of the wire to the bottom of the wire. That means the current direction is from top to bottom. The current starts flowing from top to bottom of the straight current carrying straight wire. The current starts flowing from top to bottom. The current starts flowing from top to bottom. So now it's very simple. You can see as we have observed in the experiment of Hans Christian Ørsted, that whenever a magnetic compass is placed beside a current carrying conductor, then there will be change in the direction of the magnetic compass. So here also the same effect can be observed in these all magnetic compasses which are present around the straight current carrying conductor upon the table. This is the table, and the wire is passing through this table like this, and the current starts flowing from top to bottom, and around these current carrying conductor there are magnetic compasses which will enable us to know the magnetic field's direction. How would we able to know the magnetic field direction? Just try to understand here. Here you have to note the north directions of all the magnetic compasses. The magnetic compasses would be able to show the north directions. So you have to ensure, you have to put some dots around these magnetic compasses. Let us suppose if there is a magnetic compass over here, and if it is showing the north over this side. Let us suppose this is the magnetic compass's north direction. In this direction it is showing the north, and similarly here there will be a magnetic compass which will be showing north in this direction. Here the north will be shown in this direction. Here the north will be shown in this direction. North will be shown in this direction. Similarly, in all the compasses, the north will be shown tangentially, and you have to put dots at the north upon this circle. Upon this circle, you ensure that you put a dot. So you have placed all the dots showing the north by the compass. Compass ekkada north చూపిస్తుందో అక్కడ dots పెట్టాలి. compass చూపించిన నార్త్ డైరెక్షన్ లో డాట్స్ పెడుతూ పోవాలి. అండ్ లేటర్ వాట్ యు డూ ఈస్ యు రిమూవ్ ఆల్ దీస్ మ్యాగ్నెటిక్ కంపాసెస్. యు రిమూవ్ వాట్ యు డూ, యు రిమూవ్ ఆల్ ద మ్యాగ్నెటిక్ కంపాసెస్. And after removing the magnetic compasses, I mean around this hole, you can find the dots. You can find the dots around, as we have placed dots showing the north direction. So this would be the magnetic field direction. This would be the magnetic field direction. So do we have to perform all this experiment, all this activity to know the direction? No need. Always it's not needed to perform this much activity to know the magnetic field direction. This is a simple activity to ensure that the rule which, see, I am going to teach you a rule through which you can say the direction of the magnetic field around the current carrying conductor. So in order to cross check this rule, we are performing this activity. So what is that rule which makes us very easy to know the direction of the magnetic field? Here the magnetic field direction would be the clockwise direction when the current is carried from top to bottom. When the current is carried from top to bottom, the magnetic field direction would be in a clockwise direction. It's like clockwise direction. When the current is conducted, when the current is carried from top to bottom, the magnetic field would be around in through this. When you see from the top view, you can see that the magnetic field would align, the knots of all the magnetic compasses would align in a clockwise direction. This shows that the magnetic field around the straight current carrying conductor will be clockwise direction. So we shall try to understand what is the rule behind knowing the magnetic field direction around the straight current carrying conductor in an easier manner. So what is that rule? R H T, right hand thumb rule. Right hand thumb rule. So what this right hand thumb rule says actually? See, it's simple. So now we have placed all the magnetic compasses around the straight current carrying. Now there is no need of placing these magnetic compasses around this current carrying conductor. Just very simple. You have to take your right hand, consider all of you, consider your right hand, just raise your right hand and you imagine that in front of you there is a straight current carrying conductor. Whatever the direction it may be like this, it might be like this, it might be like this, whatever the direction it may be, you have to consider your right hand and just take your thumb, just consider your thumb in the direction of the electric current direction, in the direction of the electric current. Watch, whichever the way the electric current is moving, electric current flows from positive terminal to negative terminal. Do remember that if the direction is given to you, then if star point, if it is a straight current carrying conductor, this is the rule you are going to follow. So just take your thumb and place it in the direction of the electric current. So electric current is flowing from top to bottom, so you take this thumb and put it in the direction of the electric current like this, from top to bottom. Then you curl your fingers. These are the fingers, right? You cannot turn it away. You cannot turn it in the other way. So it's impossible to turn it in other way. So only way you can curl your fingers is in this way. So just this is the current carrying conductor. Let us suppose a current carrying conductor is like this and you place your thumb in the direction of the electric current and you curl your fingers around it. The curled fingers direction, fingers a direction like the turn outunayo, that is the direction of the magnetic field. That means this is the direction of the magnetic field. So place your thumb, this is the direction of the magnetic field. Means when the current is flowing from top to bottom, you can see the magnetic field is in a clockwise direction. Similarly, what we shall do is we shall switch this battery away. Means let us take the positive terminal to the bottom end of the wire and the negative terminal to the top end of the wire. Like this, we have switched the circuit in other way. Means the current starts flowing from top to bottom. Now immediately what happens, the magnetic compasses will realign in opposite direction. The magnetic compasses will realign themselves in opposite direction. Initially, the magnetic compasses knots are all aligned in a clockwise direction. Now they start arranging themselves in an anti-clockwise direction. Similarly, what we shall do, we shall consider a straight current carrying conductor in which the current is flowing from top to bottom. Similar rule, take your right hand, put your thumb in the direction of the electric current. That means from top to bottom, this is the direction of the electric current. You place your thumb in the direction of the electric current and you curl your fingers. The curled fingers will show you the direction of the magnetic field. The direction of the magnetic field is anti-clockwise direction. You can see it is anti-clockwise direction. So I hope you have understood the right hand thumb rule. Right hand thumb rule can be applied for a straight current carrying conductor to know the magnetic field direction around it. And I am going to introduce two symbols to you. It's very important symbols to understand the directions of different physical quantities in physical sciences. So in physical sciences, there is a general notation for two directions, into the plane and out of the plane. If something is going into the plane, if something is moving into the plane, then there is one symbol, that is into mark. If into the plane, you have to indicate it in the into symbol, cross symbol. If something is some physical quantity, you consider electric current is going into the plane. If it is going into the plane like this, you can indicate it with the cross mark and just write I beside it. That means the electric current is going into the plane, means the wire is arranged like this, the current is going into the plane. Similarly, if the wire is like this and the current is coming out of the, means current direction is out of the plane లో నుంచి బయటకు వస్తుంది. అంటే వైర్ ఇలా అరేంజ్ అయిపోయింది, అవతల ఎక్కడనో నెగటివ్ టర్మినల్ ఉంది, ఈతల ఎక్కడనో పాజిటివ్ టర్మినల్ ఉంది, అవతల పాజిటివ్ టర్మినల్ ఉంది, ఈతల నెగటివ్ టర్మినల్ ఉంది. దెన్ the current would start flowing from positive to negative, right? పాజిటివ్ అవతల ఉంది. సో అక్కడి నుంచి కరెంట్ ఈతలకు వస్తుంటుంది, మన ఈ ప్లేన్ లోంచి బయటకు వస్తుంటుంది, అంటే అవుట్ ఆఫ్ ద ప్లేన్ వస్తుంటుంది. వైర్ ఇట్లా ఇమాజిన్ చేసుకోండి అన్న, ప్లేన్ లోంచి బయటికి వైర్ వచ్చిందని ఇమాజిన్ చేసుకోండి. అప్పుడు అవుతలో ఉన్న టర్మినల్కి ఏమో, అవతల ఉన్న ఎండ్ ఆఫ్ ద వైర్కి ఏమో పాజిటివ్ టర్మినల్ కనెక్ట్ చేసినాము, ఈతలు ఉన్న ఎండ్కి ఏమో నెగటివ్ టర్మినల్ కనెక్ట్ చేసినాం అనుకుందాం. దెన్ ద కరెంట్ స్టార్ట్స్ ఫ్లోయింగ్ ఫ్రమ్ పాజిటివ్ టర్మినల్ టు నెగటివ్ టర్మినల్. దెన్ you have to understand that it is out of the plane. Then there is one notation which you have to remember. That notation is just a dot in the circle. Dot in the circle will say, just write I beside this dot in the circle, then it indicates out of the plane. The current direction is out of the plane, and here you have indicated I beside into cross mark, it indicates into the plane. So these are the two notations which you have to remember. Now I am going to make you understand, if these kind of notations are given in your textbook or anywhere else, how you have to decipher, how you have to understand these notations. So we shall try to understand the directions around the current carrying conductors which carry current into the plane, out of the plane. Same right hand thumb rule will be applied. We shall see now. It's quite easy. I hope you are able to understand. So we shall try to understand this case first. So I already told you, if a dot in the circle is given to you, this indicates that out of the plane. So what happens? See, here the current is flowing out of the plane, means the current is coming out of the plane like this. The current is coming out of the plane. Just place your thumb in the direction of the electric current. As I said previously, place your thumb in the direction of the electric current means the thumb must be placed like this, and you curl your fingers. Are you able to understand? You curl your fingers in this direction. This will give you the magnetic field direction. It's quite simple, I hope. See, when the current is flowing out of the plane, means the wire is like this, the current is flowing from into into the plane, to the out of the plane means it's coming out of the plane like this. బయటకు వచ్చేస్తుంది ఇట్లా. బయటకు వచ్చేసినప్పుడు ఏమైనది? The magnetic field. I told you magnetic field is indicated with B. Magnetic field is indicated with B. So when the magnetic field, when you consider the magnetic field around this straight current carrying conductor, this magnetic field is anti-clockwise. Anti-clockwise. Similarly, we shall try to understand the other scenario. That is also very, very simple. That is also very, very simple. We try to understand an X mark which is surrounded by the circle. That means a wire is carrying the current into the plane. Plane లోపలికి కరెంట్ తీసుకుపోతుంది. అంటే వైర్ ఇట్లా ఉందనుకుందాం. వైర్ ఇట్లా ఉంటే కరెంట్ లోపలికి వెళ్ళిపోతుంది. ఇంటూ ద ప్లేన్. ఐ టోల్డ్ యూ ఎక్స్ మార్క్ ఉంటే కరెంట్ లోపలికి పోతుందని మీనింగ్. Similar right hand thumb rule, same rule will be applied. Take your thumb and put the thumb in the direction of the electric current and you curl your fingers. This is how you will curl your fingers and you can see magnetic field would be clockwise. Magnetic field would be clockwise. Always remember the magnetic field lines, or else the magnetic lines of force would be a closed loop. So this is the direction of the magnetic field around a current carrying conductor which carries current into the plane. See, these are the general notations you have to understand the directions in the physical sciences. In your textbook, see, if the textbook is arranged like this, they will give a cross mark. That means the current is flowing into the paper, into the plane. If they gave a dot in your textbook, then the current is flowing out of the plane. From out of your textbook, మీ textbook లోంచి బయటకు వస్తుంది కరెంట్. ఎక్స్ మార్క్ ఇస్తే మీ టెక్స్ట్ బుక్ లోపలికి పోతుంది కరెంట్. సో లోపలికి కరెంట్ పోతున్నప్పుడు ఏం చేయాలా? థంబ్ని ఈ డైరెక్షన్లో పెట్టి కర్ల్ యువర్ ఫింగర్స్. ఓకే, ఇంటూ ద ప్లేన్. అంటే ఈ కేసు వస్తుంది. ఇంటూ ద ప్లేన్ క్లాక్ వైజ్. మీ టెక్స్ట్ బుక్లో డాట్ ఇచ్చాడు అనుకోండి, అవుట్ ఆఫ్ ద ప్లేన్ యూ కర్ల్ యువర్ ఫింగర్స్, you will find that would be anti-clockwise. So this is the magnetic field direction around the straight current carrying conductor. It's an activity also given in your textbook. You try to follow that. It's very, very simple. Tomorrow we are going to learn the directions around a circular current carrying loop. A circular loop ante ela magnetic field direction to the. Tomorrow we shall see that activity. I hope it's clear for you all. Bye bye.